This video is a mixture problem, and we'll soon discover that when we start reading it. But it says Sally's company wants to produce a 20-ounce coffee blend worth 54 cents per ounce. She is mixing Good Morning coffee worth 45 cents per ounce with Sunshine coffee worth 60 cents per ounce and True Gold coffee worth 85 cents per ounce. How much of each type of coffee should be used if the amount of the Sunshine coffee is the same as the other two types combined? And so hopefully you can see that they are blending coffees here and that this is a mixture problem. So the procedure I'm going to use, it would be the same as if I was mixing a chemical mixture or anything like that. So how I like to organize my data is what I envision to be chemistry beakers. And so I see they're mixing 3 kinds of coffee in order to get their final blend. So this is going to be one type of coffee. This is a second type of coffee. And this is a third type of coffee. And they're all going to be poured into this one. And so I'm going to make that the biggest so that to indicate that all 3 of these little ones are going to get poured into this big one. Okay, so let's see. I'm going to read the problem again, which I have to do many times when I'm doing word problems. So it says Sally's company wants to produce a 20-ounce coffee blend worth 54 cents per ounce. That's what she wants to end up with. That's the end product. So that information, a 20-ounce coffee, that's the amount of the final product. And so 2 things will go into each beaker: an amount and then also a price. So if you like to, you can, I think this is a pen I can use, if I can figure it out. Okay, yeah. So here I can, if you want to kind of draw a divider line in the bottom half of your beaker, you can put the amount, and in the top you can put the price. Sometimes people like to think of it like that. So she wants to produce a 20-ounce coffee. So the amount that she's going to end up with is 20 ounces. Okay. And the price of her final product is supposed to be 54 cents per ounce. Okay. All right. So she's mixing Good Morning coffee. I'm going to call this one the Good Morning coffee. And it is worth 45 cents per ounce. So I'm going to say 45 cents per ounce. With Sunshine coffee, this is my Sunshine coffee, and it's going to be worth 60 cents per ounce. With something called True Gold coffee, worth 85 cents per ounce. Okay. How much of each type of coffee should be used if the amount of Sunshine coffee is the same as the other 2 types combined? So, they don't tell us how much each one of these, so I'm just going to say X, Y, and Z. That's how much of each blend we're gonna have. And this sentence right here that says, let's see, how much of each type of coffee should be used if the amount of Sunshine coffee, which I'm calling Y, the amount of Sunshine coffee is the same as, that's my equal sign, the other 2 types combined. So the amount of Sunshine coffee is equivalent to the amount of Good Morning coffee, which I called X, plus the amount of Z, the True Gold coffee, these 2 combined. So that's one equation. The amount of Sunshine coffee is equal to the amount of the other 2 kind of coffees combined. So the amount of, another equation I can come up with, since I have 3 unknowns and I need 3 equations, is just by adding the amounts in the beakers. I'm going to take X amount of ounces of Good Morning plus Y amount of ounces of Sunshine plus Z amount of ounces of True Gold, and that's going to all get poured into here. So that amount is equal to 20. X plus Y plus Z is equal to 20 ounces. And then the last equation I get by multiplying price times the amount, which gives me the value of this coffee, 0.45 cents times X, plus price times amount, 0.60 times Y, plus price times amount, 0.85 times Z is going to equal to price times amount, 0.54 times 20. So now I have my three equations, but I'm going to clean them up just a little bit. And 0.54 times 20 is equal to 1080. I used my calculator to figure that out. So this is 10.8. So now if I was going to get this equation and shape this top one, I'm going to move X and Z to the left. And so that would be, I could rewrite this top equation right here as negative X plus Y minus Z is equal to 0. So I choose to use reduced row echelon form because we've been studying that. So I'm going to augment my matrix with the extra column. So I'm going to put 1.45, negative 1, 1.6, 1.85, negative 1, and then I'm going to augment this with my solutions matrix, which is 20, 10.8, and then 0. Now I'm going to enter this matrix, this 3 by 4 matrix, into my calculator, and I'm going to push the RREF button. So let me do that. Second matrix, edit, second matrix, edit. A is going to be a 3 by 4, so that's a 3 by 4, and then I'm going to put in 1, 1, 1, 20. 0.45, enter, 0.6, enter, 0.85, enter, 10.8, enter, negative 1, 1, negative 1, 0. Now, I'm going to quit because it gets stuck in the entering mode. I'm going to go to second matrix and look at what I entered for A and make sure I'm happy with that. 1.45, negative 1, 1.61, 1.85, negative 1, and 20. 10.8, I'm going to make sure that looks right, 0. It looks fine to me. So now I'm going to do second, quit, second matrix, math is what I want, and I want to go all the way down to RREF, and then I'm going to do second matrix 1, and when I hit enter, it tells me that X is equal to 9.25, Y is equal to 10, and Z is equal to 0.75. And so let's see if all of our conditions were met. Y has to be the sum of X and Z, and that is true. So we're going to use 9.25 ounces of Good Morning coffee, 10 ounces of Sunshine coffee, and 0.75 ounces of True Gold in order to make this blend.